Our next step is to calculate the current, this I, and I'm actually putting it as IT so I know it's the total current. So we need to find our total impedance. So ZT, our impedance, is going to be equal to our resistance plus XL plus XC. The reactance of the inductor plus the reactance of the capacitance. Just add those all up, and I'm going to get 1 kilo ohm plus 942.478 J ohms minus 0.707 J ohms, and that gives me 1000 plus, and this is pretty close to, when I subtract this, it's not going to be that much of a change. It's going to be 941.77 J, and all of that is a unit of ohms. And now my current is just going to be the voltage 1 divided by my total impedance, and that's 0.707 at an angle of 0 degrees over 1000. Oh, this is, I'm sorry, that's volts. I should make sure I put my units here. That's 1000 plus 941.77 J ohms. To be able to divide this, I need to put this into the standard form. Since it's 0 degrees, then it's all real, so it's going to be 0.707 volts divided by 1000 plus 941.77 J ohms, and calculating that out in rectangular form, that's going to be 3.747 times 10 to the minus 4th minus 3.529 times 10 to the minus 4th J, and that's going to be in amps. And now I need to, because it's a current, I need to convert this into my phasor form. So it's going to be the square root of 3.747 times 10 to the minus 4th amps squared plus 3. I put a negative 3.529 times 10 to the minus 4th amps squared. The angle at the arctangent of negative 3.529 529. It's 10 to the minus fourth. Actually, I'm not going to have to write the 10 to the minus fourth because they'll cancel out. Divided by 3.747. And my units of amps are going to cancel out. My 10 to the minus fourth are going to cancel out. And if I calculate this, I get 5.148 times 10 to the minus fourth amps at an angle of minus 43.282 degrees. So there's the calculation of my current, and notice that I do have a phase shift. So the current is not in phase or in sync with the voltage potential.